The way that textures are currently created is laborious. It's a very manual task, and it is very much based on personal interpretation, artistic license per individual. Big loss in contextuality. One of the biggest issues is the delighting fundamentals of it. It is extremely difficult to remove light from images. There's methods that are done manually, but otherwise it's still a very tedious task. And not everyone has the equipment to do these things. We have taught a computer the fundamentals of light. Let it be overcast or direct sunlight. It is constantly getting better. The fact that we can remove light from an image in seconds, rather than what will take an individual hours, is a remarkable tool just in itself. The fact that we're creating all these other fundamentals of a material, it's just icing on the cake. Physically based rendering is a principle that modern game engines and VFX programs and 3D packages use today. We can extrapolate a texture to its root fundamentals. And so you have roughness, you have albedo, and metal. And these elements, when you combine together in your engine of choice, allows us to recreate real-world properties, the way that light would bend, the way that an object would behave. It's very much a religion now in the modern VFX industry, and it allows for a level of consistency in design, because each object has its property. We know what wood has as a roughness variable. We know that metal is, well, metal. And so we're really trying to simulate reality in the best way possible.
So like all creative minds, we were not actually working one night, sitting at our kitchen island, having a beer, talking about what do you want to do next? Okay, Simon's been doing photogrammetry for 7 years. I've been doing it for 7 years. How many photos have we got? We've got probably close to 1 million photos. Like, I've definitely destroyed cameras' shutters. And so going, okay, well, so what can we do with this data? We want to improve the photogrammetry, but we also want to see what information we can pull out of it. So let's take our years of photogrammetry data, put it into AI, deep learning. We had kind of in our heart expectations of what it would be. We didn't even put in much, like we could start to extrapolate normal data, roughness data, delit data, and we were blown away.
RealityVirtual.co, the mothership, we've been doing some amazing real-world encapsulations. We are constantly thriving to try and find new ways of extrapolating reality and converting it into the virtual. And while we're doing this, we have invented a number of tools, processes, and methodologies in-house. Deep learning has been something that we've shifted to because it's allowed us to do super sampling, content-aware fill methodologies. While we're doing all this, we're gathering a vast amount of photogrammetry data and of texture data with all its base properties. Deep learning loves data. Big data is literally the thing that it breathes.
So regarding texture generation, there is so many meters of walls inside of games and of experiences. If you think of all of the different titles times the kilometers of textures that need to be rendered in the world, that basically it's a lot of walls that are going to need to be painted, and so we can't have people just manually painting all of that. So we need to create a pipeline for doing that in an automatic way, which is what deepPBR is all about.
To capture a large environment, we will go take several thousand photos. With deepPBR, you're going to be able to take just a couple of hundred and get the same results. You're not going to have to go down to the floor and capture every little crazy detail that is insane. You won't have to take mosaics of everything with 45% overlap. You're just going to get that detail and it's going to be put back into it with ease.
Basically, we're going to see what models they want to use and what kind of images they're dealing with. So we'll be able to train up more models in that space, whether it's trees or forests or buildings or statues or whatever they are starting to use it for. We'll be able to really narrow down the model to specialize, or rather be expert in those areas. In terms of the technologies that we're using, we started with basic GAN neural networks, and we've already started exploring using Wasserstein GANs to get a greater accuracy. And then we're going to start bringing in areas like transfer learning, because you really just need one model of reality and then output multiple different outputs. And it's actually been shown that having one model is actually more powerful than having multiple models produce multiple outputs. So those are some of the immediate next steps.
deepPBR is an extremely versatile tool. Virtual studio production is one that we're very excited about. The ability for a studio to go out and scan proper locations and be able to delight them completely and then have them relit in a virtual environment for actors to then place themselves into these environments is one, extremely cost effective for the studio, cost effective for everyone else as well. The ability for people to be able to go to locations that are otherwise inaccessible and shoot for film and television is a massive draw card. Because we can use this on volumetric video and other methodologies as well, that same actor that is being filmed on that green screen, we can then relight that actor to look suitable in the space where the film has been set. So real-time virtual studio production, using the lights in Unreal Engine 4 to shape the environment, will also affect the actor in the same way. At the moment, they use hundreds of people to draw frame by frame. We're talking about a completely automated process. So all of a sudden, anyone with a decent soundstage could be in an environment anywhere where anyone else has scanned it. And that is truly something that's going to allow for massive, massive content creation.
With deepPBR, we'll not only have the software online as a web service, but for clients to have this black box that will sit there, it can be periodically updated with firmware upgrades, and studios who cannot have their data leaked to the outside world. So the next Avengers movie, they don't want any chance of data being leaked. We will offer this in a air-gapped environment.
We really plan to make texture creation as fluid and as easy as possible so people can get back to being creative. The idea of being able to go around the world and travel and acquisition this data is a far more appealing job than manually being stuck behind a screen for hours on end, pushing pixels. So we're going to be adding a whole host of additional functionality to deepPBR as time goes along. Seamless tiles for one, auto tilt, auto correction of perspective, things that really allow it to be usable in a game engine and in a VFX tool with ease. You literally provide the photographs as raw, and we will provide you a texture library to complement that photograph. This is where it gets crazy. A single individual in a day could take more photographs than what a team could produce in months. The ability to literally make textures so readily accessible is extremely disruptive to the market as a whole. Very positive way. Textures become as readily available as power and the internet and water. Creates a paradigm shift in abundance. Future content will require this level of detail, a disruptive tool in all meanings of the word.